Today we're going to be talking about how to solve one-step equations. So we're going to break this down into addition, subtraction, and then also multiplication and division. So starting with addition and subtraction, we are going to be looking at two problems here. The first is going to be x plus 5 equals 13. And the second one is going to be x minus 3 equals 10. So for both of these problems, we're always going to follow the same two rules. So our first rule is going to be that we always use the opposite operation to solve. So depending on what your problem looks like, you would be doing the opposite operation. So for example, we have x plus 5. So the opposite operation of addition plus would be to subtract. So we would use subtraction to solve. The second rule that we have to remember is we always do the same thing on both sides. So same thing on both sides. So earlier I said we have to use subtraction to solve this problem. So I would write a minus 5 underneath here, and on the other side of my equation I would also write a minus 5. It helps to sometimes write a line here to divide the sides of your equation, because on the left side of the equal sign we have something and on the right side we have something else. So you need to make sure that you write a minus 5 in both spots. Once we have followed these two rules, all that's left is to solve. So when we solve, we have a 5 minus 5, which just gives us 0. So I cancel this out so that all we are left with is x on the left, and on the right we solve what is 13 minus 5. 13 minus 5 will give us 8. So our final answer is x equals 8. We're going to follow the same rules for the second problem here. So rule number 1, opposite operation. In this case I have a minus 3, so my opposite would be to add 3. Rule number 2, same thing on both sides, so that means I also need to add 3 on the other side of my equation. Once I do that, I can just solve. These will always cancel out so that I'm left with just x, and I solve 10 plus 3. So in this example, x equals 13. So now let's look at multiplication and division. So our rules are going to be pretty much the same as above. Rule number 1 is going to be using the opposite operation. And rule number 2 is same thing on both sides. So these problems are just going to be looking a little bit different. Let's start with the most basic. So we will see problems like this, 3x equals 12. Anytime you have a number right next to your x, you need to notice that this is multiplying. 3 times x is 3x. So our opposite operation of multiplication would be to divide. So whenever you see a problem written like this, you'll always be dividing that number in front. So 3 is going to be divided on both sides. When I divide on both sides, I will cross out my 3's on the left. And on this side, all we're left with is x. On the other side, we need to solve, so we need to take 12 divided by 3. And when we solve that, we get our final answer, which is x equals 4. So anytime you see a number written like this, it could look like 5x equals 20, or 2x equals 8. You have a number written next to your variable, you'll always be using division to solve. The second type of problem we'll see is something like this, where it will kind of look like a fraction. X over 3 equals 5. So again, we want to remember our rules up here. We want to do the opposite operation. So when we have a problem written like this, what it's saying is we have x divided by 3. So the opposite of our division would be to multiply on both sides. So I'm going to multiply 3 on both sides. The number that we're multiplying is always the number that is in the denominator. So 3 is my denominator. I'm going to multiply it on both sides. When I multiply, I will cancel out this entire thing. So the 3 and the 3 in the denominator will be canceled out. When I rewrite my equation, I'm just left with x on my left side. On the right side, I just solve this multiplication problem, 5 times 3, and I will get my final answer, which is x equals 15. So again, some example problems would be something that looks like this. You could have x over 2 equals 10, or 3x over 5 equals 20. You can still start the same way, and you could just multiply the denominator on both sides. This one is a little bit more tricky. If I were to solve this problem and I multiplied 5 on both sides, I would want to make sure that I keep this 3x here, solve on the other, and now we can see that this actually looks like the problems we saw above, right? We have 3x equals 100, and we know how to solve those already. We'll use division, so that we have x equals 100 over 3. An exception to this is sometimes we might see problems with fractions. So as an example, we might see something like 2/3 x equals 9. So for these types of problems, you can use the method that we just talked about, where you multiply 3 on both sides and then divide it by 2. Another method, though, that you could use is to multiply by the reciprocal. So the reciprocal would be the fraction but flipped. So 2/3, the reciprocal of that would be 3 over 2. And we would want to multiply that on both sides. When we have this reciprocal now, and we need to rewrite the problem, these fractions would always cancel out. So you'll always cancel out your reciprocal and the original fractions. You'll just be left with x on the left side. On the right side, you'll need to solve this. We can write a 1 underneath the 9, and we just multiply across. So 9 times 3, which is 27, and 1 times 2, which is 2. And if you can simplify the fraction after that, or you can leave it as an improper fraction. So there's 2 ways to solve these problems. You can either multiply the reciprocal on both sides, which means you flip the fraction here, or you could solve it like we just did over here, where you multiply the denominator on both sides, rewrite, and then divide on both sides.